Well, let's start with the red curve is a graph of function f, and the blue line is a tangent line to the function at a given point. Now we're looking at this point. And as you can see that the tangent line has a negative slope right here, that means we can think about the first derivative as a slope of the tangent line. So the first derivative should have a negative value, right? And that's where we start. All right. Now, if we move the point to the right of the graph as x increases, what's going to happen? The slope of the tangent line has been flattened, and the first derivative functions increases as x goes to the right, which makes sense because the slope was started at like a very steep negative slope and now it's less steep negative slope, which makes the first derivative values increases from like big negative values to smaller negative values. And it's keep going up to a point where the slope of the tangent line is 0, which means you can see that the tangent line here now is a horizontal line. And at this point, the first derivative equals to 0. Later in the course, you will learn that this point here is a critical point of a function f. All right, now let's keep moving. You can see that the behavior of the tangent line changed after the critical point. So it was a downward slope, negative slope. Now it becomes a positive slope for a little while. And then it starts changing its behavior again, as now it's reaching to another critical point where the slope of the tangent line is changing from positive to negative. Okay, this is another critical point of the function. All right, let's keep moving. Now you have a negative slope. That means the value of the first derivative has been negative. It's going up again to another, tangent line, reaching to another critical point, right here. And then if we let the points moving to the right, you can see that now the slope of the tangent line has been like increasing. It's getting steeper, steeper, and steeper, and the first derivative value just keeps increasing as x goes to infinity at this point. Well, let's start here. We have the green curve is the graph of the first derivative. The orange line is the tangent line to the first derivative. And the purple curve is the graph of the second derivative. At this point, the slope of the orange line is positive, meaning the value of the second derivative is positive. We move the point to the right. You see that the slope of the orange line is being flattened out to a point where it becomes a horizontal line right here. Okay, that is where the second derivative value is 0. Later in the course, we'll learn that this is one of the inflection point of the graph. Right, and we let the point keeps moving to the right, and the tangent line is changing its behavior again after this point. And again, this is another inflection point. All right, and if it keeps moving to the right, then you can see that the tangent line has been getting steeper, steeper, and steeper. That means the second derivative function, which is going up, keep going up to probably positive infinity. There we go. The graph of a function f and its first and the second derivative functions.